Hello everyone. So we have a very good question from the chapter of Newton's law of motion. Okay, this question will help you revise more or less the basics of this question. Okay, this question involves drawing free body diagrams and writing all the equations. So yeah, let's start with this. So we have got this drawing over here, drawing of the system over here, and it says that the mass of block A is 1 kg and that of block B is 2 kg, right? At t equal to 0, a force 10t is applied as shown in the figure, and we have to find the velocity of B when, uh, I'm sorry, when B loses contact, we have to find the velocity of A. Okay, so yeah, let's begin. So first, let's draw the, all the force, how it's being applied. Okay, so this is the body B. So the mass of B is 2 kg, right? So 20 Newton is a force is being applied by this body on the ground. Okay, we have got a tension over here. Now tension also depends on time. I'll show you how. So we have got a tension here, we have got a tension here, we have got a tension here. Since the strings are massless, so the tension will be the same everywhere, right? I hope you know this concept. There's tension here, there's the same tension here, and the same tension here. Okay, so let's look at what this force can be. You see, the value of force is equal to 10t, right? This is equal to the two, see, you've got two tension forces over here. Na? You have got this tension force and this tension force, which will add up to 10t, right? So this is equal to 2t. So the value of t, tension, is equal to 5 multiplied by time. Okay, now let's see the time at which block A will lose contact. Not block A, sorry, block B will lose contact. Okay, block B has got mass of 20 kilo, right? So this 20, it will lose contact when this mg of block B will be equal to this tension force, right? This and this have to be the same, right? So 20 has to be equal to 5t, right? So at t equal to 4 seconds, block B starts to lose contact. Okay, now at for t equal to 4 seconds, let's write the equation of all the forces for block A. So the equation for block will be, okay, let me just draw the block for you once. Let's draw the free body diagram properly. So this is the block. We have got a mass of 10 on the floor. It exerts. Okay. Not on the floor. It's the downward force basically. And we have got a T over here. Now, I mean, it's quite obvious now. This block B, it, it, it has already lost contact at T equal to 4 seconds, right? It's quite obvious that A is already in the air. It's no longer in contact. Why? Because A is lighter than B, right? And if you will like do this, make the same equation like this, you will realize that at t equal to 2 seconds, the block A had already lost contact. Okay, so it's already in air. So it's quite obvious that this force T, this tension, is greater than mg of A. Okay, so yeah, let's write the equations. This will be 5t minus 10 is equal to A, right? Ma, it will be Ma, right? But mass is 1, so it will be A. We can write A to be equal to dv dt. Why we will write it that way? Because we have to find the velocity of A. So we have to write A in terms of V. So dv dt is equal to 5t minus 10. Okay, now integrating both sides, we will now integrate both the sides. This will be from the t will be from 0 to 4 seconds, and v will be from 0 to v, right? Because at t equal to 0, this block had 0 velocity, right? So this will be v is equal to 5t square by 2 minus 10t, and this will, the limits are from 0 to 4. And if you put the value, you will find that the answer is 10 meter per second. Okay, so that's the answer for you. And in the question, we were asked the value of 5n. So 5n is equal to 10. So the value of n is equal to 2. Okay. So yeah, when you are doing such a question from, especially from the chapter of Newton's law of motion, just try to draw the free body diagram, and yeah, the rest, all everything should be fine. Okay. Thank you.